Hey, thanks for joining this tutorial, and this time we will be looking into how the solids in OpenCascade technology kernel are being composed, but we will be looking into it from a different perspective than usual. We will not be constructing a solid, but we will be decomposing a solid to its consistent parts. And it will be a bit similar to like if you would try to, learn about the engine instead of putting it together from all the pieces that lay on the table, for example, and try to assemble that by following some instruction. And we will take the engine that is already assembled and we will decompose it to its consistent parts, and hopefully that will help you learn about the core principles of OpenCascade technology kernel and how BitByBit helps you to interact with it through our Rete editor components. So we've prepared this solid to you. It's already done, right? We've used some parallelograms to create it. So here you can find the code in the script that does that. And basically we construct the face, which we extrude, and we end up with extruded solid that is now also visible on the screen, right? Let's start with the faces. So to show how faces look like, I will disable the drawing of edges. It's not really important at this stage. And let's just look at the solid that we have here. It has no edges, right? We have some rounded corners. And now let's begin to deconstruct the faces. So we have here a list of faces that we've already extracted. You see that this component is called face.getFaces. And we check a few things about this. We check how long is the list of faces, and we know that there are 18 faces in this solid. And we also just preview the data that the component outputs, and it's just 18 different JSON objects, all linked to OCC shape. And what happens if we now say to this list, extract some item on an index and show it on the screen, right? This is what happens here. So we say like get item in the list, and we provide it 0 index. And that goes to offset component so that our face gets offsetted a little bit from the solid so that it's just visible, right? And we draw it here. What happens now, if you see it, here is our face, right? This one. So it's now offsetted out of the original shape. And if we move along the slider, so let's also maybe enable edges to see it better. And now let's move this slider 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And you see all the faces here. And if I just go further, we will come to this face on the top. This face is now previewed and its index is 17, right? It's in the list. Like the list starts with 0, so that's why we don't end on 18th. We end up on 17th. And if we want to get the bottom face, we move it on 16, and you'll see that the bottom face is now selected. Let's move on to a different concept, and let's look into how many wires these faces have. Let's now disable the drawing of the edges. Let's move our index to 17 so that we get this face. And let's get back to the script. And now let's use this face that we've offsetted and extract wires from it. So now you see that we say to the face, get wires of the shape. And this component will just give all the wires that it finds on any kind of shape. So it can be also solid, not necessarily a face. But in this case, we provide it with a face, and it gives us back, if you watch it closely, we measure the length of the list, it gives back 2 wires. So that means that we can get one wire by the index of 0 and the other wire by the index of 1. And you see here also we preview the data. Now it's just 2 JSON objects in the preview data component. So what happens is if we want to check how the wire looks like, we of course draw it here. So we select it by index. It's exactly the same code that we did with the face, right? We just now have limit on our number slider to have 0 and 1 in its values. And you see in the background that our wire marked in green was selected. And if I put it back on 0, the outer wire is selected. So faces have wires, and wires limit its sort of outer regions and holes, and wires consist out of edges, right? So you can compose wire out of multiple edges. So now let's look into the code that would give us edges. And let's use the wire that we've extracted here and connect it to this component of get edges. So now if you measure the length of this list, we end up with 8 edges. And if we visualize those, so let's connect now this component of getting the edges to the extraction component of getting an item at an index, you will see that we've selected the edge on the index of 0, and it's marked as red on this screen. So what happens is that now if we increase the slider values, you will see that we select the edge on the index of 1. Now we select the edge on the index of 2. And if we go further, we select the index on the 3rd, and the 4th edge, 5th edge, 6th edge, and 7th edge. So notice that edges are not really ordered along the wire. If you're on the edge of 0 and you go to 1, you'll see that you get this edge. And if you go to 2, you can jump to another edge. And there are ways how you can order those edges along the wire, and BitByBit provides some functions for that. But in principle, it doesn't really matter. OpenCascade can still solve this phase. And actually, because of the way that this phase was constructed, we get these orders. And yeah, OpenCascade just keeps them as they are. It doesn't really care about the order, and it's up to us then, if we need to order them, we have to do that ourselves. So now we did go through all of these edges, and we understood, hopefully, that solids can be decomposed to faces, faces can be decomposed to wires, wires can be decomposed to edges, and you can also find all of those here. So if you go into the shapes category of OpenCascade technology kernel, you will find edge, wire, face, and solid. So we went through this one. So we went from solid down to a face, down to a wire, down to the edge. In general, these are the most important ones, and I hope you learned a few things here in this tutorial. So let's see each other in the next ones. Cheers.